Dear students, good morning to all. Now we will going to discuss about the chapter 9 soil, the topic properties of soil. Just recall the previous portion. Okay, listen. Soil. What is soil? Soil is one of the most important natural resources. Okay, next. What is humus? The rotting dead matter in the soil is called humus. Okay. Next, what is weathering? The soil is formed by the breaking down of rocks by the action of wind, the water and climate. This process is called weathering. Or you remember, students? Weathering. Next, what is a soil profile? A vertical section through different layers of the soil is called the soil profile. Are you remember? Okay. Next, horizons. Next, layers of soil. Soil profile. What are the types of horizon? A horizon, B horizon, C horizon and bedrock. What is bedrock? Bedrock means the below this layer is the bedrock, which is hard and difficult to dig with a spade. Okay, that is a bedrock. Next, types of soil. What are the three types of soil? Sandy soil, clay soil and loamy soil. Sandy soil, clay soil and loamy soil. That is some types of soil. What is soil? The mixture of rock particles and humus is called the soil. Okay. Next, what is sandy soil? The soil contains greater proportion of big particles. Greater proportion of big particles. It is called sandy soil. Sandy soil means big particles. Okay, next, clay soil. What is clay soil? What is the difference between sandy soil, clay soil, loamy soil? Sandy soil have contained big particles. Okay, then clay soil. Clay soil contains fine particles. Okay, fine particles. So the proportions of the fine particle is relatively higher than is called clay soil. Then what is loamy soil? The amount of large particles and fine particle is about the same than the soil is called loamy soil. Okay. Okay. Next, some activities already we learned. Okay. Okay. Listen. Listen all of you. Which type of soil would be the best for making pots, toys and statues? Can you understand the question, students? Which type of soil would be the best for making pots, toys and statues? Which type of soil? Or you remember? The answer is clay soil. Okay, the answer is clay soil. Okay. Okay, next. Now we will going to discuss about the topic properties of soil. 9.4 properties of soil. So, students, all of you take your book page number 100. Okay, take your book and take your pencil. Okay, all of you take it, your pencil, take your book. Okay, now we will going to discuss about the topic properties of soil. Okay, properties of soil. You have listed some uses of soil. Let us perform some activities. Okay, find the characters of the soil. First topic, percolation's rate of water in soil. Percolation, rate of water in soil. Listen, what is percolation? What is percolation first? What is percolation? The percolation rate. Now we will going to discuss about the topic percolation rate of water in soil. Book page number 100. What is percolation? For example, in coffee percolation, soluble compounds leave the coffee grounds. coffee grounds and join the water to form coffee. Insoluble compounds remain with the coffee filter. Remind the coffee filter have the granulates. That is a percolation. That is a filtering method. That's all. Okay, that is a percolation process. Can you understand? Okay. Listen. Percolation rate of water in soil. Listen, all of you. Just one small activity given in your book. Okay. Listen. Two different squares. 50 centimeter each. One on floor of the house. The other on the road. They filled two bottles the same size with water. The water from the bottles one each at the same time into the squares. Okay. They observed that the water on the floor flowed down was observed. Okay. Then the water was observed. Now us perform an activity to understand this. Okay. Percolations rate, the activity, page number 100, the activity 9.4. All of you see the activity. All of you see your book. See the picture 9.5. Measuring the rate of percolation. Measuring the rate of percolation. Okay, listen. For this activity, divide yourself into 3 teams. Okay, divide into 3 teams. What are the 3 teams? A, B and C teams. Okay. Okay, listen. You will be finding out of the fast water passes down the soil. Okay. Ensure that each team uses pipes of same diameter. Some suggestion for the obtaining pipe are given below. Okay, listen. The first one. If possible, get a small tin can and cut off its bottom. Okay. If PVC pipe is available, cut into 20 centimeter long pieces and use them. Next one. At the place where you collect the soil, place the pipe about 2 centimeter deep in the ground. Pour 200 ml water in the pipe slowly. For measuring 200 ml water, you can use any empty 200 ml bottle. Can you understand? Okay. Note the time when you start pouring water, when all the water has percolated, leaving the pipe empty. Note the time again. Be careful not to let the water spill over or run down on the outside of the pipe while pouring. Calculate the rate of percolation by using the following formula. Can you understand? Okay. Listen, see the formula. Percolation rate. See your book, page number 101. All of you see your book. Percolation rate, milliliter per minutes. Okay. Amount of water, milliliter. Percolation time, minutes. Amount of water, milliliter. ml means milliliter. Percolation time, minutes. Okay. Next, for example, suppose that for a certain sample, the 20 minutes for 200 ml to percolate. The rate of percolation, see your book, 200 ml, 20 minutes. Rate of percolation, 200 ml, 20 minutes to percolate. Equal to 100 ml per minutes. Okay. Next, calculate the rate of percolation in your soil sample. Next, compare your finding. Others, arrange the soil samples. Increasing order of rate of percolations. Okay, students, all of you do this activity in your home. Just do the activity. 9.4 percolations rate of water in soil. Okay, see the video. Listen carefully. The percolation rate of soil. See the video, students.
Percolation rate of water in soil. Water percolation rate of the soil refers to the rate of the movement of water through the soil as it passes through the small holes or spaces between the particles of the soil. Let us explain with the help of demonstration. Dig 50 by 50 centimeter deep hole in soil. Cut the bottom portion of an empty plastic bottle. Place the bottle in the hole. Fill the bottle with 100 ml of water. Note the time when all the water has percolated, leaving the bottle empty. Percolation rate equals to amount of water in milliliters by percolation time in minutes. Putting the value and simplifying them, we get percolation of soil is 10 milliliter per minute.
Can you understand? Next. Can you understand the video, students? The activity video 9.4. Measuring the rate of percolation video. Okay, can you understand? Okay. Next topic 9.5. Moisture in soil. Moisture, what is the moisture content? Moisture means the wet condition. That is a moisture content. Okay. Have you ever passed through a farmland during a hot summer day? Okay. Listen. Moisture in soil. What is it? So try out this activity and find the answers. The activity 9.5. Okay. Listen. Take a boiling tube. Okay, all of you see the picture first. Page number 101. See the picture 9.6. Removing moisture from the soil. Okay, take a boiling tube. Put 2 spoonfuls of a soil sample. Heat it on a flame. See the picture 9.6. Removing moisture from the soil. All of you see the picture and observe it. Let us find out what happens upon heating. Do you see water drops anywhere? If yes, where did you find them? On heating, water in the soil evaporates, moves up and condenses on the cooler inner walls of the upper part of the boiling tube. On a hot summer day, the vapor coming out of the soil reflect the sunlight. Reflect the sunlight. The air above the soil seems shimmer. After heating the soil, take it out of the tube. Compare with the soil which has not been heated. Note the difference between the two. All of you see the picture 9.6. Removing moisture from the soil. Listen. Stand, drops, boiling tube, soil sample. In a blue color, soil sample. Then burner. Okay. Can you understand? Okay, now see the video, the activity 9.5. Removing moisture from the soil. Okay, now see the video carefully.
Moisture in soil. During a hot summer day in a farmland, have you ever noticed that the air above the land is shimmering? This is due to the presence of moisture in the soil. Due to the heat, the moisture from the soil evaporates and the air above it seems to shimmer because of the condensed water vapor. Let us understand this clearly with the help of an experiment. For this experiment, we need a test tube, 2 spoons of sand, a burner, and a test tube stand. Fix the test tube to the test tube stand and place a burner below the test tube. Put 2 spoons of sand in the test tube. The water in the soil evaporates on heating the test tube and condenses on the cooler parts of the tube. This shows us the presence of moisture in the sand. We can compare the soil sample with the soil which has not been heated. Water absorption by soil. Soil has the capacity to absorb water, but do all soils have the same capacity to retain water? Let us find out through this small experiment. For this experiment, we need a funnel, a beaker, filter paper, soil samples, and a dropper. Take a funnel and place it on a beaker. Fold a filter paper and fill it with 50 grams of soil and place it in the funnel. Measure a certain amount of water using a measuring cylinder. Now pour this water all over the soil using a dropper. Keep pouring till the water begins to drip from the funnel. Subtract the amount of water from the measuring cylinder with the amount you started with. This gives the water retained by the soil. Record the results as follows. Weight of the soil 50 grams. Initial volume of water in the cylinder AML. Final volume of water in the cylinder BML. Volume of water absorbed by the soil A minus BML. Weight of the water absorbed by the soil A minus B grams. Percentage of water absorbed A minus B by 50 into 100. Repeat this experiment with different soil samples and record all the results. We will notice that the water retention capacity of all soils differ from each other. Find out which soil has the maximum water retention capacity and which has the minimum.
Can you understand, students? Next activity also. Can you understand? Absorption of water by soil. Can you understand? Now we will going to discuss about absorption of water by soil. Okay. Absorption of water by soil. How to observe water by soil. Now we will going to discuss the absorption of water by soil. The activity 9.6. Okay. Take a plastic funnel. Take a filter paper. All of you see your book, page number 101, activity 9.6. All of you see your book. Take a plastic funnel, take a filter paper or a piece of newspaper sheet. Okay, anyone. Next, fold and place it as shown in the figure 9.7. Okay. Next, the weight 50 gram of dry powdered soil and pour it into funnel. Measure a certain amount of water in a measuring cylinder and pour it drop by drop on the soil. You can use a dropper for this purpose. Do not let all the water fall at one spot. So pour water all over the soil. Keep pouring water till it starts dripping. Okay. Next, page number 102. Subtract the amount of water left in the measuring cylinder from the amount of started with. This is the amount of water retained by the soil. Okay, so record your results in your notebook. Okay, all of you see the picture 9.7, absorption of water in the soil. Okay, listen. Now we will going to discuss the calculation. Weight of soil 50 gram. All of you listen carefully in your book. Weight of soil 50 gram. Initial volume of water in the measuring cylinder UML. Okay, UML. Next, final volume of water in the measuring cylinder. Initial volume of water and then final volume of water. Initial volume of water measuring cylinder UML. Final volume of water in the measuring cylinder VML. Can you understand? See the book, page number 102. Volume of water absorbed by the soil U minus VML. So minus U minus VML. The weight of water absorbed by the soil U minus V gram. Listen carefully. The volume of water absorbed by the soil U minus VML. Okay. The weight of water absorbed by the soil. Soil means gram. Absorbed by the water. The volume of water absorbed by the soil U minus V ml. Weight of water absorbed by soil U minus V gram. So 1 ml of water has weight equal to 1 gram. So next, percentage of water absorbed. Percentage of water absorbed. Percentage of water absorbed. Listen carefully. U minus V divided by 50 into 100. Okay. But repeat this activity with the different soil samples. Would you set the same results for all the sample? Discuss the results with your friends and answer the questions. Okay, now we will going to discuss the questions. Okay, which soil, all of you take your pencil, write the answer near the question. Okay, so all of you take your pencil. Which soil would have the highest percolation rate? Which soil would have highest percolation rate? Which soil? Sand soil. Write the answer. Sand soil. S-A-N-D. Sand soil. You write the answer near the question. Next one. Which soil would have the lowest percolation rate? Which soil? Sandy soil. Which soil? Sandy soil. The answer is sandy soil. Write the answer, students, in your pencil. Sandy soil. Next, Bojo heard from the neighbors that 8 to 10 days after the rain, the level of water in a pond or well rises. Which type of soil will allow water to reach a well faster in greater amount? In greater amount. The answer is it allows the rainwater. Listen carefully. All of you listen carefully. Bojo heard from his neighbor that 8 to 10 days after the rain, okay, the level of water in a pond or well rises. Which type of soil will allow water to reach as well faster and greater amount? Sandy soil. Okay, which type of soil? Sandy soil. Next, which type of soil retain the highest amount of water and which retain the least? The answer is sandy soil. The answer is also sandy soil. Why the answer is sandy soil? The sandy soil are loosely packed. So, which large air spaces. Okay, which large air spaces. Next, last one. Can you suggest any method to let more rainwater percolate and reach the water ground? The answer is it allows the rainwater to reload the groundwater level by replacing the underground. It can be constructed to refill the borewell or to support the water infiltrations on the surface. Okay, that's all the answers. Next class I will give the answers, questions with answers. Okay. Next topic 9.7 soil and crops. Just 1 second, all of you listen. Absorption of water in the soil. Just see the video activity. Okay, 9.6 activity video, absorption of water by soil. All of you see the video. Listen carefully.
Absorption of water by soil. Take a paper and weigh it on a balance and note the reading. Now add 50 grams of soil sample and weigh again and note the reading again. Take 10 ml of water and fix the funnel on an iron stand. Take a filter paper, fold it and place it on the funnel. Put the soil into the funnel and pour the measured 10 ml of water drop by drop on the soil. Finally, measure the amount of water collected in the beaker. This will give the absorption percentage. We can calculate the water absorption percent of soil by using the following formula. We get percentage of water absorbed equals to U minus V into 100 divided by 50 equals to 10 minus 5 divided by 50 into 100 equals to 10%. Here 50 grams of soil is utilized.
All of you see, listen, the water absorbed U minus V by 50 into 100. U minus V divided 50 into 100. But 10 minus U 10. Okay. 10 minus 5 divided by 50 into 100. The answer is 10%. So, the 50 gram soil is utilized. Okay. See the video.
U represents initial volume of water in the container.
U represent initial volume. Okay. V represent the final volume. Listen.
V represents final volume of water dipped into container. By solving the equation we get the percentage of water absorbed equals to 10%.
Can you understand? Absorption of water by soil, the activity? I hope to understand you. Are you clear, students? Okay, next we will go to soil and crops. Next topic 9.7 soil and crops. Okay, different types of soils are found in different parts of India. In some parts there is clay soil, in some parts there is loamy soil. Different types of soils found in India. Okay, different types in our states, in our areas. Okay, in some parts there is clay soil, some parts there is loamy soil, while in some other parts there is sandy soil. Soil is affected by wind. Soil is affected by wind, rainfall. All of you underline the word. Okay, different types of soils are found in different parts of India. So, students should underline the word. Some parts there is clay soil. In some parts there is loamy soil. Underline the word. Other parts there is sandy soil. Okay. Soil is affected by wind. All of you underline the word. Soil is affected by wind, rainfall, temperature, light and humidity. Okay. Soil is affected by wind, rainfall, temperature, light and humidity. These are some important climatic factors which affect the soil profile. Some climatic factors to affect the soil profile and bearing changes in the soil structure. Okay, the soil climatic factors as well as the components of soils. See your book page number 103. As well as the components of soil. Determine the various types of vegetations and crops that might grow in any region. Okay, that grow in any region. Underline the word. Determine the various types of vegetation and crops that might grow in any region. The clay and loamy soils are both suitable for growing cereals like, underline the word students, clay and loamy soils are both suitable for growing cereals like wheat and gram. Underline the word. Which one of the soil? Clay and loamy soil. Such soils are good at retaining water. For paddy, soils rich in clay and organic matter and having a good capacity to retain water or idle. For lentils and other pulses, underline the word, other pulses, loamy soils which drain water easily or required. For cotton, sandy, loam which drain water easily, which drain water easily and can hold plenty of air, are more suitable. Page number 104. Crops such as, underline the word, crops such as wheat or grow in the fine clay soils. Underline the word, students. Crops such as wheat or grown in the fine clay soils because they are rich in humus. Because they are rich in humus. Underline the word, because they are rich in humus and very fertile. And very fertile. Can you understand, students? Okay. Listen. The next one questions. Give your book. Which kind of soil would be most suitable for planting rice? Soil with a higher or lower rate of percolation. The answer is paddy. Which kind of soil would be most suitable for planting rice? Which plant? Paddy plant. Paddy plant means what? Rice crops. Okay. The paddy soil which low percolate rate water would be the most suitable for growing paddy. Okay. Because it will allow the water to remain in the field for a much longer time. Okay. Can you understand? Which kind of soil would be most suitable for planting rice? Paddy soil. Soil with a higher or lower rate or percolation? With low percolate rate of water would be the most suitable for growing paddy. Because it will allow the water to remain in the field for a much longer time. Okay, can you understand? Okay, next class I will give the answer. Okay, this is the answer. Next class you write. I will give the answer these questions. Okay. Can you understand, students? Okay. Okay, listen. They enter the data in the following table 9.2 in your book 104. So all of you fill the table 9.2. Next class I will give the answer, discuss, then I will give the answer. So all of you fill this table 9.2. Okay, next soil erosion. See the box, page number 104. What is soil erosion? What is soil erosion? The removal of land surface by water, wind, underline the word, students. Removal of land surface by water, wind or ice is known as erosion. Plant roots firmly bind the soil. In the absence of plants. In the absence of plants. Soil becomes loose. So, it can be moved by wind and following water. Erosion of soil is more severe in areas of little or no surface vegetation, such as desert or bare. Desert or bare lands. Underline the word desert or bare lands. So, cutting of trees and deforestations should be prevented and effort. Deforestation means the destroying forest in trees. Deforestation. Okay. Should be prevented and effort should be made to increase the green areas. Increase the green areas. Can you understand? Soil erosion. The removal of land surface by water, wind and or ice is known as erosion. Okay, underline the word. Now see the video, soil erosion. Now see first the picture, soil erosion. This is a soil erosion picture. See the picture. Next, see the video, soil erosion video. Listen carefully.
Soil erosion. Can you explain what is soil erosion? Well, soil erosion is a process of removal of the top layer of the soil. But what causes soil erosion? Basically, it is caused by the action of wind, water and ice. These are the agents of soil erosion. Apart from natural agents, human activities like cutting down the trees also causes soil erosion. But how? Plant roots bind the soil in place and prevent it from being washed away. So, if there will be no trees, floods will occur which will leach the soil nutrients, and eventually the land will become barren, which cannot be used for vegetation. Therefore, more trees should be planted in order to prevent soil erosion.
Can you understand, students? Soil erosion. Okay. Next class we will discuss about chapter 9, book back question and answers, and some tables in your book. Okay. So listen. Next class we will discuss them book back question and answers. Okay. Okay. That's all. This class over. Okay. Read in your book line by line. Okay. Okay, students. If you any doubt, you contact with me. Your homework, send my personal WhatsApp number. Okay. So, thank you, students.